In this lesson, we'll finish looking at the respiratory system by taking a look at pulmonary function tests. We're going to see that there are four pulmonary volumes that we can calculate. Then we can take those volumes, add them together to come up with different capacities that give us a good idea of the function of our lungs, right? How well they're working. All right, so basically pulmonary function tests are going to monitor pulmonary function by measuring both rates and volumes. In this lesson, we're going to be focusing mostly on the volumes. Now, our total lung volume is divided into a series of pulmonary volumes, of which there are four, and then we can use those volumes to calculate different capacities, and we're going to learn four different capacities. Now, the tool that we use to make these measurements is called a spirometer. And if we use this spirometer, we can actually make a gram or a graph showing these different volumes and capacities. So basically this red line right here represents our breathing. We're going to go into this in more detail, but any line that goes up is an inhalation. So this one going up here is an inhalation. This one going down is an exhalation. Right? This big guy here, inhalation, and then this one going down, exhalation, just to give you an idea. And we can see at the bottom, this would record over time, and then this would record the volume, either in milliliters or in cc's, which are cubic centimeters, same type of thing. All right, so we'll get into this graph in a little bit more detail now. This is the spirometer. This is the tool that we can use. This is a very simple one where you would breathe into the mouthpiece, and then there would be a dial right up here that we can actually measure the different volumes that we would be blowing into, and we can record those. In a hospital, in a a doctor's office, a pulmonologist's office, they use more intricate ones that are computerized than this one here that you may see in a lab. So let's take a look at the four pulmonary volumes, and then we'll learn once we learn those volumes, we can calculate the capacities. And again, the reason we do this is it helps us to maybe do a diagnosis on a patient to see maybe what kind of condition they have or how well they're breathing, but also to monitor their progression. Are they getting better? Are they getting worse, right? Sometimes people that have emphysema, they're going to get worse over time. It's a progressive disease, so it's a way that we can actually measure that and keep track of it. So the first of the four volumes that I'd like to go over is known as the tidal volume or the resting tidal volume. And very simple, this is the amount of air that we do during a normal breath, right? We're not doing any type of exertion. Just like you're sitting here, listening to this lecture, more than likely you're just sitting quietly, breathing in, breathing out, right? Breathing in, breathing out. That would be the tidal volume. And it's roughly about 500 cc's or milliliters of air for both males and females, right? They're pretty equal. So what would that look like on the spirogram? So let's say we'll start right over here where my cursor is, right? You would put that a spirometer in your mouth, and then you would take a breath in and you would breathe in. This would be the inhalation, and then you would breathe out. Inhalation, exhalation, right? So again, we're moving about 500 milliliters of air or cc's of air, and that is known as the tidal volume, right? Tidal volume. The second volume that I'd like to go over with you is the IRV. This is the inspiratory reserve volume. This is the volume of air that can be inhaled, right? Inspiratory, in addition to the tidal volume. And we'll go back to this in a second. So let's say over here we take a breath in, normal, breath out, normal. Then they're going to have you take a breath in, but not breathe out. You're going to continue to breathe in air, as much air as you can possibly breathe in. And I remember doing this test myself. I would feel like my lungs were inflating like way up high under my clavicles. That's how much air I was trying to bring in. That would be the inspiratory reserve volume, right? So we take a normal breath in, and everything above that normal breath, that's your IRV. Now you can see it very variable between males and females. Males have bigger lungs, bigger even chest cavities, so they're going to be able to bring in more air. Again, this is on average, right? There's exceptions to the rule. So the IRV in a male would be about 3,300, in a female close to 2,000. Again, you can either say milliliters or cc's, it's the same thing. Okay, the third volume is the expiratory reserve volume. We usually abbreviate that the ERV. This is the volume of air that can be exhaled, right, expiratory, beyond the tidal air exhalation. Again, I'll go back to the numbers in a minute. So let's just say, again, you do a normal breath in, normal breath out, normal breath in, normal breath out. But instead of breathing in from this normal breath out here, you're going to breathe down, out as much as you can. You're going to blow out the air. They're going to even encourage you to, blow, blow, blow. Keep breathing the air out. And you think you have every drop of air out of your lungs, then you can take a breath in. That is the ERV, right? So again, from here, when we breathe out normally, down, this is the expiratory reserve volume. They're pretty close in both males and females. In males, it's about 1,000, and in females, it's about 700. Now, the last volume is the residual volume. And when you do this test and you blow out all the air that you possibly can, and you think, you know what, you don't have anything left, believe it or not, your lungs completely don't like deflate. There's still air left inside. That is the residual volume. And so that's the volume of air in the lung after complete exhalation, right, after ERV. And again, this is also pretty close, right? 1,200, 1,100, about 100 cc's of difference. So what does that mean? So you just did your ERV, right? Expiratory reserve. You blew out all the air you thought you possibly could. You couldn't blow another, half a second even of air. That's how much air you blew out. Look at this. All of this here represents air that is still in the lung. This would be the residual volume, right? The residual volume. Okay, so those are our four volumes. Again, tidal volume, normal breathing, inspiratory reserve volume, right, the air that we can take in after a normal breath in, and then expiratory reserve volume is the amount of air that we can blow out after we blow out a normal tidal volume, and then residual volume is everything that's left in the lung after you've again blown out as much air as you can. So now that we know the four volumes, we can use those to measure what we call the capacities. So the first capacity is the inspiratory capacity, right? This is the amount of air that we can pull into our lungs after we have completed a normal quiet respiratory cycle. And basically it's the sum of the tidal volume plus the IRV, the inspiratory reserve volume. Let's take a look and then we'll go back to the numbers. Okay, so say we do a normal quiet cycle, right? Breathing in, breathing out, and now we take the normal breath in, the tidal volume in, and we add it to the inspiratory reserve volume. So we're basically adding this line here to this line here, and that would give us the IC, which is the inspiratory capacity. All right, so we're just adding the two inhalations. Just to give you an idea of the numbers, so you can see here in a male it's about 3,800. Again, remember before the IRV in a male is much higher than a female, so there is a big difference here. About 3,800 in a male, and then about 2,400 in a female. The functional residual capacity, excuse me, right? This is the amount of air in our lungs after we have completed a normal quiet respiratory cycle. Let's take a look. So let's just say, because we have it here, here's our functional residual capacity. So let's just say we're doing a normal quiet breathing, in, out, in, out. After we had done the exhalation, right, this is the amount of air in the lung after a normal exhalation, right? It would include our expiratory reserve volume plus the residual volume. Okay, so all of this is the functional residual capacity. The third capacity we're going to call vital capacity. This is the maximum amount of air that we can move into and out of our lungs in a single respiratory cycle, right? The maximum amount of air that we can move into and out of our lungs in one single respiratory cycle. And basically, it's the sum of the ERV, the expiratory reserve volume, plus the tidal volume, plus the inspiratory reserve volume. So let's take a look. Okay, so where's our vital capacity? Right here on this one. So all of this, it would be the inspiratory reserve volume plus the tidal volume plus the expiratory reserve volume. So it would be something like this, guys. If you started here, let's say you take a normal breath in and then a normal breath out. Now we start to measure. We're going to add this going up, inspiratory reserve, I'm sorry, tidal volume in, inspiratory reserve going in, and then breathing out all the air that we could possibly breathe out, right? So it's everything we can breathe in and then right away go into everything we go out. That tells us a little bit about the vital capacity. So you can see here it's approximately 3,600 in an average size adult. That's about 5'8", and then you can measure up or down based on that. So it's increased or decreased 1,500 for each inch above or below. On average, in males, it's about 4,800 cc, and females 3,100 cc on average. Again, it's very variable. Finally, the last measurement, if we took all of these measurements and added them together, right, we took the functional residual capacity plus tidal the tidal volume, that capacity, and the inspiratory reserve. We kind of add up all the air that we have in our lungs. This is known as the total lung capacity. Right? It's the total volume of air in our lungs, and we add it by adding the vital capacity to the residual volume. Right? So our vital capacity here plus the residual volume. And we're kind of adding up everything. And you can see it's approximately 6,000 cc's in a male and about 4,200 in a female. Again, totally very variable, right? It could be 5,000 in a female if the female's larger. It could be 5,000 in a smaller male. So it's very variable. So that's our pulmonary capacities, and again, these are used on a regular basis to assess the function, the health of our lungs.